In this video, I'm going to show you how to approach a revision exercise. We will look at revision exercise 1, numbers and operations, and we will divide it into two parts. So this will be part 1, and you will find this on page 59 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to succeeds. Now, question 1. I see a list of numbers, and then from this list of numbers, write down the smallest natural square numbers, irrational numbers. Now, let's first go to the table of content of the textbook. Now, if I look in the table of content, just to find where I can quickly revise that, I will see numbers and operations. This is the chapter. So real number system. I think we will find a nice revision there. So let's go to the textbook to page 2. So let's insert page 2. Okay. Now I'm just quickly going to go through this, or you can just read through that, and that will just give you a quick revision of this. So, complex numbers divide into two groups. It divides into real numbers and imaginary numbers. Now, real numbers is the ones that we're going to use in school mathematics. Imaginary numbers is the ones, if you press it on the calculator, it will give you an error. But take note that you see, if you press square root of -4, or the 4th root of -2, or the 6th root of -6, what do you notice? Do you notice that that is all even numbers? Okay, and the reason why is because a negative times a negative, if you have 2 or 4 or 6, the result will always be a positive. And that's why it can never end up into a negative. But if you press on your calculator, say for example, -27, and you take the cube root. Okay, so if you take, and you can press, or you can just do it. So if you press cube root -27, it's going to give you an answer of -3. Because if you multiply a negative with another negative, with another negative, so you have 1, 2, 3. If there's an odd amount, the sign will always be negative. Even amount, positive, that's why that sign should have been positive. But odd amounts will give you a negative result. And that's why you can also say, for example, that's 5, you can say -10. You can press that on the calculator and it will also give you an answer. Okay, so now real numbers divide into rational numbers and irrational numbers. Now, rational numbers, can you still recall? Rational numbers is the numbers that you can convert to a fraction which have a numerator and a denominator. So that one is already perfect because it's 2/5, numerator, denominator. If it's 2.8, you can say 2 and you can say 8/10. Which can simplify to 2 and 4/5. The same there. So as soon as it stops, then you know, okay, it's not. If it's one place, it's over 10. If it's two places, it's over 100. But if it's like this one, and I'm just going to make it a bit bigger that you can see better. You can also check in your textbook. If it's like this one, there's 1, 2, 3, 4. So if I want to write this one as a vulgar fraction or a fraction, I'm just going to say -3, 2, 5, 6, 8, that is a 5. And it's going to be, and I count how many zeros. There was 1, then 1 0, 2, 2 0. So this will be 1, 2, 3, 4, because there's 4 places after the comma. And you can simplify that. So all the ones that can be written to a fraction where you have 1 on top and 1 at the bottom is rational numbers. The ones which if you press this √3 on your calculator, √3, you get 1.732050 808. It only stops because there's no more place on the calculator, but it actually goes on. And because it goes on, you don't know how much you put it over 1 0, 2 zeros, 4 zeros, so you cannot write it as a fraction where you have a numerator on top and a denominator at the bottom. Okay, a vulgar fraction. So now this stops again, but this rational numbers divides into integers. Now what is integers again? Integers is like, it's almost like if I say whole numbers, but I don't want to use, but it's not having a comma. So, but it can be negative and it can be positive. Okay, so all the numbers without commas is integers. Okay, fractions is the ones with commas, or a part of it is a fraction. And then you get negative integers there. Okay, here comes the whole numbers. Now, or counting numbers. Remember it like this. There's a O, so that's the reason why it starts at 0. So it's going to be 0, 1, 2, 3. Counting, there's also a 0, 1, 2, 3. But that divides into 0, but natural numbers. Do you see any O? No. That's why it starts at 1, 2, 3. Okay, will you remember it like that? And then you have, only has one factor, it's 1. And then prime numbers. Now what is prime numbers? And I'll show you now in the next example. Prime numbers is only having two factors, the number 1 and the number itself. So what can divide? So it's only 1 and 2, 1 and 3, 1 and 5, 1 and 7, 1 and 11, 1 and 13. But not 15, not 14. The next one will be 17. Okay. The next one will be 19. That will be prime numbers. And all the rest in between, because there was the 1, and then I start with 2 and 3, which is the prime number, but all the rest in between, 4, okay, 5 is again prime, but 6, so 4, 6, and so you get 4, 6, they are composite numbers. Okay, and then maybe just a final thing here, and then I revise it nicely. Square numbers is if you take, say for example, let's just get the pen. If you say 1 squared, 2 squared, 3 squared, and that result, that answer, that is square numbers. Cube numbers, if you say 1 to the power 3, 2 to the power 3, 3 to the power 3. So that's to the power 3, and this is to the power 2. Okay, now let's go back to our question. Now, as soon as I start, that was the revision exercise here. Okay. Now let's do it quickly now. Okay, so from that list of numbers, just want to get a nice pen here, nice color, and I'm going to start. Number 1A. From the list of numbers, write down the smallest number. Now, smallest will be, if there's a negative, it will be a negative 1. And the smallest one will be negative 16. Okay. A natural number. Now, can you still recall natural numbers? If you go back, I'm not going to, but you can just quickly go back to your page and just go and recall what was natural numbers. So, natural numbers was 1, 2, 3. It was not whole numbers. It was not 0. So, it was natural numbers is 1, 2, 3, and going on. So if okay, that's it's not natural. That's a comma, not natural. That's also a comma, not natural. Oh, but look at this one. Always work it out. So 12 times 12 is 144, and 144 will be a natural number. But it's the best to write it in the original form. So in this case, you can just say 12 to the power of 2. A square number. Now, can you remember the square numbers? The square numbers was, okay, let's just see quickly in this case. It was, now from the list of write down, it's not a square. Square numbers is only positive. Not only positive. So out, 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 out. So it's again, and it can happen that the number can repeat. So although 12 is a natural number, it is also a square number because it's 144. Okay, and then an irrational number. Now, what was irrational numbers? Now, can you recall? Irrational numbers was the ones which you cannot make a vulgar fraction. So that can be a fraction because you can say -4/1. That can be a fraction -16/1. That can be a fraction 12/100. This can be, but this one, if you press square root 7 on your calculator, you will get 2.645751311, and it only stops because there's no more place on the calculator. So basically the irrational number will then be square root 7. This is a very easy question, so make sure you go always through the basic list and that you just recall it. Now, write down 40 as the product of its prime numbers. Okay, so it's like prime factors. You did it in grade 8. But now, just to go back, let's again go to my table of content, just to see where did we do something like that in the textbook. Okay, real numbers, I think it will still be in real numbers before that, so let's just go to the next page. We were on page 2, and then we go to page 3 in the textbook. The relationship between numbers. Let's make it a bit bigger. There is prime factors. And now, just go quickly. If you can recall it, excellent, just do it. But otherwise, just go back and first revise it before you approach the question. Okay, so in this case, prime factors. So what factors of a number which are also prime numbers? Okay, the prime factors of 20 is 2 and 5. Use the prime numbers as divisors. So this is so the prime numbers, let's just get another color. Prime numbers must be my divisors. So that's 2, 3, 5, 7, 11. It's that little squares that you made in grade 8. So you start with 20 because they ask the prime factors of 20 of 2 and 5. So 20, and then you start with the first divisor, 2. And then you say 20 divided 2, that's 10. But continue with 2 until 2 cannot go in equally anymore, and then you can go to 3. So 2 can go in 5, 3 cannot, but move on to the next one. 5 can go in 1. Okay, and this is in factor form, and this is in index. But if I ask the prime factors of 20 as 2 and 5, I'm just telling what prime numbers I use. But most of the time, they want me to write it out. Okay, so let's just go back to the question. So we use the prime numbers as divisors. Remember that. Right, let's go back to the question. Okay, write down 40 as the product of its prime numbers. So let's just start there. That's easy now. We're just going to say, okay, there is my 40. It's always nice to use that blocks. And can you still remember? I should have swapped the colors, but it's fine. So this is my prime numbers. And what is my prime numbers? It's 2, 3, 5, 7, 11. So I start with 2, and 2 can go in 20. And then 2 can go in 10. Remember, I continue with 2 until 2 cannot go equally anymore. 5. So 3 cannot, 5 can go in. And I continue until I have 1. And then I write it out as 2. Usually we write it already as 1, 2, 3, 2 to the power of 3 times 5. And there I was writing it as the product of its prime numbers. Okay. Okay, then number C. 3 different pairs of prime numbers each have a sum of 40. Okay, now if they say prime numbers, the best will be is that you first write down the prime numbers, that you continue with the prime numbers. So just go on with the list. What was after 11? It's very good if you know at least until 50, the prime numbers. Otherwise, just test it. So it was 13. And then it was 17, and then it was 19, and it's not 21, not 20, but 23 again, 24, 25 not, 26, 27 not, because 3 can go, 29, 30 not 31. Okay, I think up to here we are safe almost. 31. Let's just quickly see. I think yes. 31, 32 is not 3 not 4 not 5 not 6 not 37. Also not 38, 39, 40. Okay, so first write it out. And now start playing with combinations. So if I say, okay, 2, and they want every time a sum of 40. So that would, 40 minus 2 would be 38, which is not correct. But let's try 3. Can you see? Because 40 minus 3 will be 37. Do you see that? That's nice. Okay, and now you can go 5. 40 minus 5 will not work. 40 minus 7, will that work? No. Oh, 40 minus 11. What is 40 minus 11? That's excellent. So 11, that's going to give you 29. Okay, there's the next one. Okay, and then every time just say 40 minus 13, that's 27. It will not work. But let's try this one. 40 minus 17, it's 23. That's excellent. Because 23 is also there. Okay, so just move on. Take 40 every time and just subtract that prime number and see if the answer is also in this list. And then you have your extra combinations. That's just a nice play around calculation. Okay, let's do, I'm going to clean here. And I'm going to start with number 2. Now, number 2 is also grade 8 work, very easy. Maybe just approach. I'm not even going to go back to revise it because I think most of you are familiar with that, but I'll show you how to approach it. Okay, so if I look at number 2, on a winter's day in Brussels, the maximum temperature was -2. Wow, very cold. That's maximum. Okay. The minimum temperature was 11 degrees lower. Do you see what that means? It means down. So it was -2 and I subtract 11. Okay, and that's all there. You don't have to use your calculator. You know, if the signs are the same, I just add the numbers and I just keep the sign. But not a problem. If you want to check it, you can use your calculator. So that was also an easy one. Okay, let's look at the next one. Number 3. In 2018, a toy cost 52.5 reals in Brazil. 1 real is 3,63. Work out the cost of the toy in Namibian dollars. Now again, this isn't very easy because you just do direct proportion. And I'm just going to revise, but I think I want to show you quickly because I want to show you how to approach if you maybe struggle with one like that. So let's go again to the table of content, just briefly. And we are going to say it's money. Do you see here? Money and household. Okay, so if I'm looking here at the money, it looks here from page 42. So let's just go to page 42. Or from there on. Let's see if that is going to help me. Oh, here it is. Exchange rate. So before you start, you can quickly just go through the one in the block, and if you really struggle, you can look at the video of this one, or you can try this one and then look at the answer before you approach the revision exercise. So given that $1 is 11.44 pesetas, change this to pesetas. Now, how does direct proportion work? This is my dollar side and this is my pesetas. So I write $1 is 11.44 pesetas. 3,500, change dollar, change it to pesetas. So make underneath pesetas X and write that underneath the dollar. Now direct proportion, I just cross multiply. So I say 1 times X is X. This times this, and I'm getting that answer. Very important. Or it's just going to help you. Always the one where the variable stands. first multiply that one, that it ends up on this side, because it's just more familiar to you if it ends up on this side. So, okay, and there is my answer. So, direct proportion, let's try it. Okay, in 2018, a toy cost 52 reals in Brazil. One real is this Namibian dollar. Work out the cost of the toy in Namibian dollars. So first, I will just go and write my first row. So 1 real equals 3,63 Namibian dollar. Okay, so it was cost 52. So I write it underneath the reals, 52.50, and I make this x. So 1 times x, remember what I said? We are going to do direct proportion. We're going to cross multiply. So start with the one with x. So x times 1, that is just going to give me x. And that's going to give me 3,63 multiply 52.50. So 3.63 times 52.5 equals, and I'm going to get an answer of 190. Now remember, money, we always approximate to 2 decimal places. So in this case, I'm going to, so if you do final answer, don't put, you can say therefore, this means therefore, it's going to be, because it's underneath the Namibian dollar, 190. This 5 is going to make this one a what? A 8. So it's 190.58. Okay. And in this one, so the next one, so this was now my final answer. Number 4. The distance between Windhoek and Cape Town is this. Correct to the nearest 100 kilometers. Copy and complete this statement. Now, as soon as I'm reading it and I see that bigger and equal and smaller, I think of limits of accuracy. So let's just go back to my table of content and see what did we do at limits of accuracy. Do you see limits of accuracy? Page 24. So the best will first be to go to page 24. In your textbook, go to page 24. Okay. Now let me just quickly refresh or revise with you the following about limits of accuracy. Okay. Now limits of accuracy was actually, and I'm just going to explain it here, I approximated something. Okay. I did approximation. And now, limits of accuracy want to tell me, before I did that approximation, there is the approximation, what was the answer? Now, it's a nice one to just go through this one. The distance from Otavi to Shumak is 70 kilometers, but that's to the nearest 10 kilometers. Find the set of possible outcomes before it was rounded off and state the lower and the upper bounds. Okay, so if it was 65 and you approximated, it will be 70. If it was 66, that 6 makes that one a 7. 67, 68, until 674. 74 will still stay 70. But 75, what will happen to 75? It will become 80. So 75 will not be included. But that was now just to the nearest unit. It could have been all the in-betweens also. So I'm actually giving you the approximated value. I just wanted to write it here. Can I just write it? I'm giving you the approximated value. And I just want you to think back. What could it be? All that possible outcomes that will give me an answer of 70. That's what I'm interested in. But now, you don't have to write all of them down. You can just say where it starts and where it ends. Now, if you look, you will see that it starts at 65 and it's all the numbers in between, not only that integers, up to 7, but 75 is not included. So it's always like this. We write the distance, and now because the 65 is included, we make an equal sign. But the 70 is not included. Do you see? And that's why the 75, sorry. Let's just correct that. The 75 is not included, and that's why we don't make it. But that's the long way of doing it. The short way of doing it is I always read the question. If they say, to the nearest 10, then I take that value of 10 and I always divide it by 2. Always. And I get 5. So if it was to the nearest 100, I will say 100 divided with 2 and I will get plus minus 50. If it's to the nearest 1,000, I will take 1,000 divided by 2 and it's plus minus 500. But that was not the case. They said to the nearest 10. So I divide it by 2 and I get 5. And I subtract 5 and I get 65. And I add 5 and I get 75. Okay. And then I'm just going to write it in. This is always the lower bound. And this is always the upper bound. Okay. Okay. And that's how you do it. So if you look at this one, just want to see, this is a very basic one. There's a few exceptions. The radius of circular bound, this one, I did this one in the previous video. Maybe we can just look to the nearest hundreds. I will just say 100 divided 2. So I will subtract 50 for the lower, add 50 for the upper bound. Okay, but let's go back to the question. I just want to see. Okay, let's go back to the question. Okay. They can go more into this, and it will be good if you revise everything, but this is a very, very, very basic one. So let's just first look at the very, very basic one. So the distance between Windhoek and Cape Town is 1,000, correct to the nearest 100. Copy and complete this statement. So I just take 100, divide it by 2, I get 50. So for the lower bound, I'm just going to say 1500 minus 50. So that's going to be for my lower bound, and I get 1450. And for my upper bound, I'm going to say 1500 plus 50, and it's going to be 1550. And then I just want to move this a little bit, and then always remember it's like this. So this is the distance. So it's usually with an equal sign, no equal sign, because the lower bound is always on this side, the upper bound is always on this side, and the upper bound is not having an equal sign. Okay, very basic one. And you can go back to and revise a little bit more if you are preparing for a test. Okay, but this was a very basic one. And now the final one I want to look in this video is about a private school has these students. There are these girls, what percentage? So I see the word percentage. So as soon as I see percentage of the students are girls on day this, I go first to my table of content. And I'm just going to look, where is percentage? Oh, it looks there at page 9. So go back to your textbook, go to page 9. Okay, I think this is going to be on page 10 in this. It's just a little bit one page on. Because there's the nice summary of grade 8. And this is a beautiful summary that will help you. So let's just see this. What was the things that we did in grade 8 and 9 mostly? So there's 4 different types. So So the one is express one quantity as a percentage of another. So 8 kilogram as a percentage of 20 kilogram. So you just make it a Wilker fraction and you times with 100%. Just make sure the units are the same. If they say find a percentage of a quantity, so then in this case, because that percentage means divide by 100, multiply 20, and that's going to be 8 kilogram. And then percentage increase and decrease. Okay, first I like to do it like this because this one reflects to this one. So the percentage increase and decrease, find the amount. So if I'm saying increase 20 by 15%, so the best, you can first work out what is 15% and then add it, or you can say 15 plus 100 is 115, and always the one that you want, I want 115, put it over 100 and just multiply it by the 20, and I get 23 kilogram. And then the last one, Levy's mass increased from 20, so I actually use this one, this is why I'm writing it there. Then Levy's mass increased from 20 to 23. Find the percentage increase in his mass. So first get the difference, that's 3, and now I'm making a percentage like, so I've put it 3 over the original one, which was 20. Multiply 100%, and that will give me 15%. Okay, let's go back to the question. That was a very basic one. In part 2, we will look at one that's not so basic. Okay. Okay, just want to clean that. Okay, so in the first one, so let's just start reading it. Number 5, last line. A private school has 240 students, so that's all the students. There are 131 girls. What percentage of the students are girls? So it's like making it a percentage. It was like that number 1. So it's just going to be 131, a very easy one, over, and that is going to be, what is the total? 240. And to make it a percentage, I just multiply by 100%. And that will give me an answer of 54.6%. More girls. Okay. Then the next one, number B. On one day, 6.25% of the 240 students are absent. That's using a percentage. That was like number 2. Work out the number of students who are absent. Okay, that is again very easy. So in this case, it's 6.25. So I'm just going to say 6.25. And that percentage means it's out of 100. And I'm just going to multiply it with 240, the total. And if as soon as I multiply that, I will get 15 students. Okay, and that will be the final for part 1. In part 2, we will focus on reverse percentage and the rest of the revision exercise.